We'll look at another fuel burn example. We're overloaded by 350 tonnes and we're going to use 46 tonnes per day at a speed of 14 knots with a boundary 33 degrees south, so that's a limiting latitude between summer and winter zone. We're leaving this position in Chile and going to this position in New Zealand, so 20 south, 70 west to 41 south, 175 east. So we've got 20 south, 70 west to 41 south, 175 east. So that's the route we're travelling, and there's a limiting latitude as we go along here of 33 degrees south. First part of these problems, always you have to calculate the distance to steam to bring the vessel to be at a winter displacement or winter marks. Very standard. We have to steam 2556.5 miles. Always with these, we use Napier's rules to calculate the shortest distance to the limiting latitude. So put the values through Napier's, and we find that that distance was 3065.9 miles. This distance here exceeds the fuel burn distance. We now discard this value, so this particular calculation now is not involved in anything to do with the problem. We've simply established that the distance to steam there is too much, and looking at the sketch there, what we've done, we've gone to our limiting latitude here and it's taken us 3065.9 miles, which exceeds the fuel burn distance, so we discard that distance. And we'll now solve the problem by using a great circular formulas twice. So we already know the distance A to C, this distance here, as it is the distance already calculated to be at the winter marks. So the unknown in the great circle formula we're going to use is the d long here, P, because we know obviously the PA and PV, which is the limiting latitude, or PC I've called it there. So we know PC and we know PA. We know the distance, so we're going to find the d long. So I've written the values down here, PA, PC, and we know AC. Put them in the formula. As you can see there, I've transposed the formula, and we can work out that the d long is 45 degrees 46.4. So in this first great circle area here, we've found this d long of 46.4 because we knew the distance, which was the fuel burn, which takes us to the limiting latitude, and we knew PC and PA. Now we can subtract that from the total d long, and that will give us the remaining d long to use to solve C to B. So I've put here, we can now apply this d long to our initial longitude to calculate the longitude at reaching the winter mark, then take it from our final longitude, and we find that the d long remaining is 69 degrees 13.6, which I've indicated there. Of course you could just get 70 west to 175 east, get that total d long, subtract this value from it, 46.4, and you'd find that that was 69 13.6. So now we've calculated this value here. We can now use our great circle formula, but in this instance, of course, we're finding the distance C to B because we've just established what the P value is here. So we're going to find that distance by great circle, and we find that's 3265.5. So we can add the two together, and that gives us the shortest legal distance, and that would solve the problem for us. So we'd add these values here to give us the final answer. So hopefully you can see what we've done there. We've had to discard the 3065.9 that we first calculated because it exceeded the fuel burn distance. Therefore the first great circle was the fuel burn distance, and the second great circle was the one that we calculated. We added the two together, and that gave us our shortest legal distance.